Okay, so functions. Let's all read this together. A function is a relation in which each x has exactly one output y. Each input x has one output y. Okay, so every x has a single y. That's the basic rule of a function. If a relationship between two values follows that rule, we can call it a function. Every x has only one y. Every input has only one output. Okay? And that's going to lead to some interesting results that we'll see in a minute. Okay? So every x has only one y. I'm going to keep on saying that. So it makes a little more sense for you. But let's just see. These are examples of things that are functions. And I want you to pay attention to the x values and the y values, okay? And the ordered pairs. So we're going to start looking at ordered pairs. Look at every x value. We got 1, -3, 8, and 5. Do any of the x value numbers repeat? Do they pop up more than once? That's what makes them a function. The x values never repeat. Okay. Now, do the y values repeat? Let's see, we got 7, 5, 2, 4. They don't repeat either. So that's actually the best type of function, where x and y don't repeat. Let's take a look here at the other function that is a function. We got 3, 2, -3, -7. Did any of the x values repeat?
No.
That's why it's a function. How about the y values? Yeah. Yeah. Guess what? That's okay in a function. Okay. Later on, when you get into higher level math, you'll find out that it's not a one-to-one function, but that means something that's something that you'll learn about later on. But for now, it's okay if y values repeat. So let's just write that down. Okay if y values repeat. Okay. So we just learned a couple things. In a function, x values cannot repeat, but it's okay if y values repeat. Okay? Let's take a look at a couple things that aren't functions and figure out why they're not. Let's look at our first set. Do we have any x values that repeat? Yes, we sure do, right? The -4s. You see them right there? That's why it's not a function. Let's find out what makes the other set, the second set there, not a function. What do we have repeating? We got 4s and 5s, right? 5 here, 5 there, repeating. 4 here and 4 there, repeating. So x values repeated. They came up more than once. And that's going to be the case each and every time for some disqualify something and make it not a function. All right. Let's talk about the domain and range. Okay. The domain is called the independent variable. The domain is called the independent variable. And it's all the possible inputs. So it's all the possible x values. Almost all the time we associate domain with x values. Okay? So let's look at the range. The range, we call it the dependent variable. And we'll get into those details more later on in this unit. But it's all the possible outputs. So that's the y variable. Okay? So the domain, x variable, range, y variable. Any questions on that? Okay, let's do something very hard right now. It's going to be super difficult. Let's list the domain. Now, whenever we list a set, we're going to use those squigglies. Okay, what's our domain values? I'll give you the first one, the number 1. Then we have -3. Then we have 8 and 5. We just listed all our x values. Okay, let's do the same thing with a range. Okay, so that's going to be 7, right? Then we have 5, and then 2, and then finally 4. They don't have to be in order, and they don't, and you can have them repeating. So in other words, if say in the range side, say 4 came up like twice or 3 times, you would only write it once. You only list how many that it came up as part of your range. You don't have to list 4 4s or 3 4s, however many came up. Okay, so here's the first thing we're going to do. We're going to state the domain and range for each of the following and determine if it's a function or not a function. Okay? So let's do it. Let's do number 1, guys. Let's write D for domain. And then we're going to write it in set notation. So we're going to put those squigglies. And let's list our x values. Let's see, we've got 3, 2, -4, and 0. Okay? Then we have the range. Let's just put an R for the range. And let's list those. We've got -4, 0, -1, and -3. Now the big question. Yes, it's a function, or no, it's not a function. How can we tell? How are we going to tell if this relation, this connection of ordered pairs is a function or not? Yes? Yeah, the domain doesn't repeat. None of the numbers came up more than once on the x side, right? So, yes, it's a function. So let's just say function. Okay? Got it. So let's continue. Let's do the same thing for number 2. Let's list the domain. -7, 3, 0. 3, we already came up with the 3, right? So we don't write the second 3, but we will write the -6 that came after it. So there we go. That's our domain. Don't have to list the 3 twice. Okay, let's write down the range. 20 rather. Then 5. 5 again, so we only list it once, 6 and 9. So now the big question. Yes, it's a function or not a function? Yes. Yeah, let's see. The 3's, right? Yeah, because the 3's came up more than once on the x side. It's okay on the y side if they repeat, but so that makes it not a function. Okay, let's do number 3. Domain, here we go. D for domain again. And we've got 3, 2, 0, -2, -5. Okay, range. 11, 6, 2, 6 again, and 27. And now the big question. Yes, it's a function, or no, it's not a function. Yes. There was repeating, right? But it was on the output, the range side, so that's okay. So this is a function. Okay. Now we come to an ordered paired table. I like these. You know why? What's our domain? All the x numbers, right? There's your domain. What's my range? There's your range. So why write them again if they're just listed for you, right? Okay. Let's just scan it real quick and see if we're okay for a function or not a function. Yeah. It's looking good. I don't see any repeating numbers here. 0 is only there once. 1, 2, 3, 4, 5. Yeah. This one is a function again. Okay. So far we've looked at ordered pairs. We saw an input-output table. That's what we call this. Let's take a look at a few more. Now we're going to look at something called mappings. You guys ready? Let's turn the page. Anybody still writing? I see a couple people still writing, so I will give you a little bit of time. If you're done, go ahead and look at the other side. Okay, ready to move? Here we go. So over here we have 4 mappings. These things are called mappings. So these are called mappings. And mappings relate items in the domain to items in the range. Items in the domain to items in the range. Okay. So we got these 2 mappings relating everything here to everything there. So we already have the domain then. This is our domain. No need to list it. It's there for us. That's our inputs. Let's write down the range. Okay. And it's real easy to tell. So in a mapping, it's obviously showing you the connection, right? Do you see it? -19 is connected with -14 in the range. -18 in the domain is connected to -20 in the range, and so on and so forth. What would a non-function look like? What are we looking for if it's a non-function? Gabriel.
To obviously details in the slots like the mapping, same things like to make it different.
Yeah.
Like 2 numbers.
So let's pick -8. -8 is hooked up with -10, right? But say it was also hooked up with negative 12 in the range. You'd have another branch going that way, right? That would make it not a function. So that's what we're looking for not a function. Branching out to 2 or more. Is that happening anywhere here? Nope. So function. This is definitely a function. The way it was expressed, mind you, this was like in an upper level. Well, it was my second year of college, so it was I had taken a few math classes by then. But the first time I ever heard this, and then it made sense. The domain values cannot cheat. The range values can cheat. Think of it that way. The domain values are not allowed to cheat in a function, but the range values can cheat. Or put another way, x's are not allowed to cheat and y values are allowed to cheat in a function. Okay? So think of it that way. Let's move on and look at this one. We have a domain and a range. Do we have a function? No, we don't. 0 on the domain side is linked up to -1 and 0 on the range side. Because of that, x's are repeating and not a function. Okay? Try out 7 and 8 on your own. Just identify the domain and range and function, not a function. Let's do it. Do it on your own. So just like we did before, decide the same thing for 7 and 8. So obviously this is domain and range. Yes, it's a function, or no, it's not a function for number 7. Who's cheating? -9, yeah. Not a function. Okay. Here's our domain for number 8. And here's our range. Function or not a function? Function, yeah. All those -1 and 0 on the domain side should probably talk to each other because 8, yeah. Okay. Oh, we got another one too, huh? -2 on the range side. Both 7 and 8 are mapping onto -2. Okay, but that's okay in a function. All right. So now we identified domain, range, and functions on mappings. Let's look at graphs. Okay. So let's start with a domain. Domain. We're going to have to list it again like this. How do we determine the domain when we just have points on a graph? What are we looking for? The x values, yeah. So if I look at this point here, what's the x value? What am I looking for? Look at the x-axis. What number would that be? 1. Let's assume we're counting by ones. So that would be 1. This would be 2. This point would be at, what is that? 3. And then the final point would be at 4. 1, 2, 3, 4. Okay. That's an ugly brace, but okay. Range. So what are we looking for to find the range numbers? The y-axis. Let's start from the top. So here, what number is this at? At the top? 4? So 4. And let's just work our way across. Or down, I should say. So this would be at 2. If I'm at this point and I look across, it's at 2. Then we're down on the negative side now. Negative 1. And then finally negative 2. Did any of the x values repeat? Nope. So it's a function. All right. So the next one's the same situation. We're going to start with a domain. All right. So let's start with, remember, for the domain, we want the x values. We'll just start from the negative side and just work our way across and look at the points. What numbers are in our domain? Negative 16. What's the next one? Help me out, please. And then negative 8 twice. That's important because guess what? Do we have a function? No. Okay, one here, one there. They're repeating x's. Okay. What's our next one after negative 8? Just work your way across. 4, right? Yeah, it's 4. And then 8. And then finally 16. Thank you. There's our domain. Let's do the range. Okay. For the range, we're going to start either at the top of the y-axis or at the bottom of the y-axis and work our way either down or up. So let's go up. If I'm going up, scan across, what's our first number we hit? 16, followed by 12, followed by 8, and then 4, and then negative 8, and then negative 16. Okay. Negative 8? No, I put 8 and negative 8. Yeah, 8 and negative 8. They're both in there. And what did we say? Function or not a function? Not a function. It happened right here. Do you see it? One point and then above it another point. You would get 2x values there. So this is not a function. Notice what kind of line did I draw? How would you describe that line that goes straight up? It's a vertical line. Notice I drew a vertical line and it touched the points more than once. Touched it here, touched it there. Okay? Okay. Go ahead and turn the page over. And when we have regular continuous graphs, yes. If the vertical line touches 2 or more points, it's not a function. Yes. Absolutely. Okay, turn the page to the last part. And there's a test that we can do on graphs to determine if we have a function or not. It's called the vertical line test. Okay? So if you can draw a vertical line that touches the graph more than once, it is not a function. Okay? So basically, here's the key part. Vertical line touches graph more than once, not a function. Okay? That's the important part here. So this is real simple. Take a graph and it says, excuse the typo. Why this is true is it would mean an x value is going to 2 different y values, and by a function, every x has only 1 y. So look at this. If I'm able to do the following, you just pick any point, just some random location, and if it touches the graph 2 or more times, yes function or not a function? Not a function. So this is not a function. Okay. Now, will there ever be the case in this? We have just a plain old run-of-the-mill line. How many times did it touch? Will there ever be an occasion that I draw a vertical line and it touches this graph more than once? No, not on a line, just a line with a slope like this. Never. So this is a function because it only touches once. So if you want to remind, okay, I'm not sure why, only touches once. It only touched this uno time, and that's the only time it would touch it. Okay? This thing down here, it's a quadratic function. Oh, I just gave it away, didn't I? Is it a function? Yeah, because look at this. Even though it has this funny shape, right? How many times will it touch the graph? Oh yeah, it touches. It touches once, but it'll only touch it once. Any vertical line you graph will only touch it once. So this is a function. Okay? And how about this one? Not a function. Some people said, well, there's certain places, like if I draw a vertical line here, it's only going to touch once. But the rule is if you're able to. Am I able to draw a vertical line that touches more than once? I am able to do that. And because of that, not a function. I'm able to do this. Pick this location here. And because I'm able to do that, where it touches 1, 2 times, not a function. Okay. So the assignment today are 2 IXLs where you're going to look at these situations. You're going to look at domain and range, and then is it a function or not a function? Okay.